Okay, so we are recording now. What we want to do with this is we want to do the complete work, all three steps of this equation to find the 5 key points. And if you'll remember, all three steps look like this. Step 1 is in blue, step 2 is in green, step 3 is in red. Step 1 contains 5 different tasks. Find the amplitude, find the period, find the scale, find the starting point, find the stopping point. Step 2 is to make a table of the correctly calculated 5 key points, and step 3 is to actually sketch one period. So that's what we're going to do with this function right here. Y is equal to 2 sine of x. All right, so if we're going to do this, first thing we need to do is step 1, which is find the amplitude, find the period, and then something called the scale, right? And then the starting point and the stopping point of the period. Now we've already been through this discussion. The amplitude's easy. The amplitude is always the number that's tagged to the sign of the cosine word. It's always the number that's right in front of it, and it's always an absolute value. So our amplitude is 2. That's not a big deal. The period, you'll remember, is always the formula 2 pi divided by b. And b is always the number that's between the sine of the cosine word and the x variable. Remember, x is always an angle in radian measurement. So in this case, our period is 2 pi over 1. B is 1, so our period is 2 pi. Remember, what that tells us is that the cycle, or the wave that this graph is going to make, that's going to tell you how far it goes along the x-axis. So the period is nice. We know it takes 2 pi units to make one complete wave or cycle. What we don't know is where does it start and where does it stop, and we don't know this thing called the scale. Right? The scale, there was a formula. It's always the period divided by 4. Right? So the period in this case is 2 pi over 4, which is pi over 2. Now the reason we do a scale is because the ultimate goal is to find the 5 key points. And so what we need to do in order to find the 5 key points, we need to notice that the 5 key points always happen in equal intervals. So the scale tells us that in this particular graph, at every pi over 2 intervals, you'll have a key point. You'll have a minimum, you'll have a maximum, you'll have an intercept. Okay? That's what the scale is going to do. And then the last two things were the start and the stop. Start had a formula. It was bx minus c is equal to 0, solve for x. Now in this particular equation, bx minus c looks like this. It's 1x minus 0. Some of you may be going like, well, where'd you get 1x minus 0 from? Well, if I take this equation up here, and if I expand it out into y is equal to a times the sine of bx minus c plus d, that would look like this. It would be y is equal to 2 times the sine, and remember, what's inside these parentheses has to simplify to x, so that's 1x minus 0 plus 0. That's how I know that bx minus c is 1x minus 0, because what's inside the parentheses has to simplify to just simply x. That's how I know that, right there. There's no other combinations of 1s and 0s that would work. All right, so if I solve this for x right here, not a blue marker, add 0 to both sides, divide by 1, x is going to be 0. Go with that so far? Same idea with the stop. Let me move this up just a little. The stop is the same idea. It's bx minus c is equal to 2 pi. So in other words, 1x minus c minus 0 is 2 pi. And then if I do the solving, add 0 to 2 pi, you get 2 pi. Divide 2 pi by 1, x is still 2 pi. So what we've just done with these 5 little tasks under step 1 is we have found out the amplitude, the period, the scale, the starting point for the period, and the stopping point for the period. And these are all going to be important in helping us to find those 5 key points. Now, as an aside, today in this class we're going to work mainly with, or we will work with C and D being 0, which means there are no shifts. So what you're going to find out is that when C is 0, your starting point will always work down to be 0, and your stopping point will always work down to be in the period. That's when C is 0. Now tomorrow, when C is not 0, that'll be a little bit different. But while C is 0, you'll find out that's pretty much going to be the case. Starting point is 0, the stopping point is going to be the period. And if you take the difference between the two, that should always add up to the period on there. Right, so we have these things up here, and I'm going to erase these stuff in green here. Get that out of the way, and then I'm going to save a little bit of room here. Pull a little bit of room. I'm going to minimize, group off and minimize this stuff right here. Okay, we can still see it. Alright, so that's step 1. Step 1 is to do all that stuff in blue. Step 2, what we need to do is actually come up with the 5 key points. Alright, so remember back in algebra and math before that, when you did your graphing, what you did was you made a table of values, you picked a number of x's, and you plugged them in, you came up with their y's. That's what we're going to do here. Except we can't just pick any old x. We have to pick x's that are strategic and targeted. But the way I do this is I do x, and then y, and there are 5 key points. So I make, let's see, 1, 2, 3, 4, 5. So I just make a table like that, and the top columns, top of each column is going to be the x, the bottom is going to be the y. Now, like I said, the x's theoretically can be any number, but we don't want them to be. We want them to be strategic. Well, the first x right here is always going to be the starting point. And we started at 0, so the first x is going to be 0. The last x is always going to be the stopping point. So this x right here is going to be 2 pi. So our first and our last x are always the start and the stop point. Always, in every case. I'm going to erase this, rewrite it, get it out of there. Same thing with the 0 and all that. Okay, so our first number, our first x is always the starting, last x is always the stopping one, and then the in-betweens are going to come from the scale part of things. So we know that this point right here is just simply going to be the previous x plus the scale. And what's 0 plus pi over 2? It's just simply pi over 2. This number right here comes from the scale. Every one of these right here, every one of those 5 x's are pi over 2 units away from each other. So if my first x is 0, my next x has to be 0 plus pi over 2, which is just simply pi over 2. My next x after that comes from this right here. I'll draw an arrow. It comes from my previous x plus the scale. So if I take pi over 2 and I add pi over 2 to it, I get 2 pi over 2, which is just simply pi. My next x, erase that, arrow down and all that good stuff. My next x comes from taking the previous x and adding the scale to it. Right now, I use my little fraction formula, the rational formula, which is going to be 2 pi plus pi over 2, which is 3 pi over 2. So that just simply comes from adding pi over 2. Now, you know, do you have to actually work this off to the side? Well, that's up to you. 2x, no, that's 2 pi. This number right here comes from taking this pi and adding to it the scale number, pi over 2. Well, this is like saying pi over 1. All right? I need to find a common denominator and all that, but the way I do it is I multiply 2 times pi, this 2 times this pi, and then add this 1 times this pi, which is a pi, and then multiply 1 times 2.
Where did you get the plus pi?
1 times pi is pi. It's the rational rule. It's a over b plus or minus c over d is equal to, I'll find out a room. This is a way to add fractions. You're not required to do it this way. And honestly, you can do it the best way you know how to add fractions. This is the way I do it. It's a times d plus or minus b times c over b times d. So what I did was I multiplied these two right here, then I multiplied these two right here, and then these two right here on the bottom. That's why I get 2 pi plus 1 pi divided by 2, which is 3 pi over 2. Okay? You good with that? All right, and then you can go through the math and figure out that if you take 3 pi over 2 and add the scale pi over 2 to it, you're going to get 2 pi. All right, so that's how we get all of our x's. Well, how do we get our y's? Well, we simply substitute in each x value into the equation and evaluate it through. All right, so we have this. Y is equal to 2 times the sine of x. But x now has a number associated with it. It is 0, because that is our first x, 0. Now we need to evaluate this. Well, y'all, y is going to be 0. And let me explain why. It is not because 0 times everything is 0. Because when you look at this, you say, well, this is a 0, and you're multiplying times sine, and that times 2, that makes everything 0. That is not why the result is 0 in this particular case. You have to remember that these numbers right here are angles and radian measurement. So this 0 right here is not the number 0, it's 0 radians. And this is where you got to go to your unit circle. What is the sine of 0 radians? It is 0. And what is 0 times 2? It is 0. So our answer to this first y is 0. But again, it's not because you see that 0 there, you just multiply everything by 0. That doesn't work that way. It's because 0 is a radian angle, and the sine of 0 radians is 0. 0 times 2 is still 0. So we find our second y by plugging in pi over 2. Now we need to evaluate what is the sine of pi over 2. Well, that's 1. That comes from your unit circle. The sine of pi over 2 is 1, and 1 times 2 is 2. Now, some of you in here may already see a pattern with your y's. Hopefully, you're going to see that when we're done, and I'll show you a little shortcut where we don't have to go through all these steps. Still have to go through a few of them. All right, so the next y, I should say that y is going to be 2. So the next y is going to come from plugging in pi for my x. The sine of pi radians is also 0. 0 times 2 is still 0. So that means I put a 0 for my y there. I have 3 coordinates now. I have the coordinate 0, 0, the coordinate pi over 2, 2, and the coordinate pi 0. The next one, I'll substitute in 3 pi over 2. The sine of 3 pi over 2 is negative 1. Again, that comes through your unit circle. Negative 1 times 2 is negative 2. And then my last x, my last x is 2 pi. The sine of 2 pi is 0. 0 times 2 is 0. So that completes my table right there. Notice these numbers are all just combinations of your zeros and amplitudes. Notice that? Now that's going to be the case when C is 0, or when D is 0. When D is not 0, that's going to change. That's not the case today. But we got all these from doing this evaluation. I also want to point out to you, because the next thing we need to do is graph. When you sketch the graph, you need to label it correctly. And this is a sketch, though, so it's going to be a little, it's not going to be perfectly exact, but it should be fairly exact. The x-axis, our first x is going to be 0. Our next x is pi over 2. Our next x is going to be pi. Our next one is 3 pi over 2. And our last one is going to be 2 pi. And if we look at our y values, we know the highest y value we go to is 2, and the lowest one we go to is negative 2. Now we just plot points. Our first point is the point 0, 0. 0, 0. So we put a big old dot at the origin, 0, 0. The next point is pi over 2, 0. So we go over to pi over 2, and we I'm sorry, I said that wrong. Pi over 2, 2. We go over to pi over 2, we go up to 2. That's our next dot right there. The next one is pi over 2, pi 0. So we go over to pi, we don't move any, we have a dot there. The next one is 3 pi over 2, negative 2. That's going to go over 3 pi over 2, down negative 2. And then the last one is 2 pi 0. So really all you have to do now is just do a general curve that shows you then that's how your graph is formed. So this is all 5 steps, all 3 steps with all the work. Now I wanted to point something out to you earlier, that had you not, let's say that you got this far, I'm erasing these right here. Let's say you'd only gotten this far, and you got tired of evaluating. Well, if you'll just look at what you have, your first number is 0, 0. Your next number, let me, again, this is just showing you how you don't necessarily have to evaluate all those one by one. So I'll just do it this way. I'll do it this way. Redraw it. So that was pi. That was 3 pi over 2. That was 2 pi. So we did this. We did 0 and 2. Right now, if you know anything about sine and cosine graphs, you can tell that pi over 2, 2 is going to have to be a maximum. So the next logical point that's going to happen has to be an intercept, which means then that this has got to be a 0 up here. And again, the next logical point has got to be a minimum. So that's got to be negative 2 right there. And then the next logical point, again, because we know we're dealing with the sine, and sine starts at the origin and does all that, then our next point would have to go back up to here. So I'm just saying that if you catch these patterns here, you can figure out what your y's are going to be without having to actually evaluate all 5 of those on there. All right, now a couple of other things about sine and cosine graphs before I turn this recording off. One is that there is always a median line that goes through the middle of all these graphs, a horizontal median line. In this case, it's the x-axis. That's a line that just bisects the whole function. That's going to be important because our amplitude is 2, which means that the distance from the top number on the y-axis to the bottom number on the y-axis is going to be a distance of 4. But that also tells you that the curve will be 2 units above a median line and 2 units below a median line. That's what your amplitude also tells you. Another thing to notice is that without any kind of shifts, without any kind of C or D, sine will always start at the origin, and cosine will always start as a maximum or a minimum point. All right, so as far as the steps are concerned, in blue step 1, in green step 2, and in red step 3, that's what it means to do all 3 steps.